Okay, hello everyone and welcome back. I am Aditya Bansal and we are back at learning Python. And my goal is to learn Python by solving some Leetcode questions and then reading documents and also to go over some of the uh, big things, some nuances. But currently in my process, I am in learning solving lead code questions because I think that's a good way to practice DSA. I have done some of the lead code questions before in C++, but I want to get a refresher in Python. So that's what I'll be doing today. Now, I don't know much about Twitch. So let me just rephrase that again. Now, I don't know much about Twitch, but I started streaming again after a long time yesterday. And then I was surprised to have my first live viewer yesterday. And now, and later, I've also found out that someone gifted me a sub. So, which was also a nice thing. Let me just adjust my screen. Okay. Let me figure out some things. Okay, I have some notifications. Let's connect this. And then I can just figure this out. 1 second. Okay, so let's get started. Uh, so I don't know much about Twitch. Like, let's start again. Uh, so I don't know much about Twitch, but I just started streaming again after a long time on Twitch yesterday. And I was glad to have my first live viewer yesterday. That was great. But today I received this email that someone gifted me a sub. So thank you very much for gifting me a sub. Uh, to Wild Annie, and I will be checking out this channel. So thank you for that. Now let's get started. We will be solving lead code questions. So I am following this study plan with 100 top 150 interview questions. I have solved some questions before related to array and strings, two-pointer approach, sliding window, matrix. I'm leaving these hard questions for last because I don't think it's worth it to spend too much time dwelling on them right now. But I will make sure to get back to them once like I've completed the easy and medium questions from this list. So our next question will be spiral matrix. Let's see what this is about. So the medium question, we are given a M into N matrix and we have to return all of the elements in a spiral order. And Our example is we have to go 1, 2, 3, and then down, and then back, and then in a spiral. So I have solved this before in C++. That was a long time ago. So let me see if I can utilize Python's data structures and algorithms to approach this in a new way and like with a fresh eyes. So one thing we can see is that first we will go in the first row, we have to iterate straight to the end. Then we go straight down to the end. Then we go to the. So first we go 4 steps, 3 steps, 4 steps, 1 step, 3 steps. So I guess like we can do some sort of number manipulation to see like how many steps we have to take in each direction. Because 1, 2, 3, and then 1, 2, and sorry, 1, 2, and then 1, 2, and then 1, 2, and then just 1, and then just 1. And similarly, it goes 1, 2, 3, 1, 2, 1, 2, 3, just 1, and then 1, 2. So after like two times, we are reducing this by 1. So it can go something like count how many elements there are, which is like if we get length of matrix 0 minus 1. This many times we have to iterate the first time, and then we have to go down. So first we will keep updating I till this is 0, and then we will keep updating this many times till like this is 0, and then we will update these two variables, and then instead of going plus, we will go minus. So that's one thing that can work, because essentially we're flipping the sign, and then we're reducing the count by 1, because at each moment we went here. Now we don't have to cover this, and we don't have to go to the top and then bottom. So at each given time, we are reducing 1 step. Uh, Let me see if we can try to code something like that. Number of rows is equals to length of matrix, and the number of columns is equals to length of matrix of 0. And we have been given that both of these will be at least 1. So if it is just 1 by 1 matrix, then it just like stays at the same position. So we don't have to worry much about that case. Okay, so we have to consider like what happens if there is only one element in the matrix. In a 1 by 1 matrix, we also have to cover that element. So we have to go like for, because if we trade 0 to 0, then that will be missed. So we have to make sure that we start at this position. So our result will be a list. And then we can start by putting result dot append matrix 0, 0. This is where we are starting. And then we can have like I and J. For how many times we will iterate? We will iterate for so we have to iterate till number of rows and number of columns. These two of our variables is 0. So while num rows is greater than 0, or num columns is greater than 0, because we will keep reducing these numbers. So like at the end, so some logic, and then we will update num rows and num columns. First, we have to start going sideways. This is not like a matrix where we have like guaranteed it's not like a square matrix. So it can be like a number of rows can be just one. So if number of rows is just one, then we have to go like from this position. We cannot go anywhere. And then we have to just go down and add that to the result. So we can have our starting position as 0, 0. While either one of these is bigger than 1, bigger than 0, we will move forward. Which will be, so I have to update I till like number of rows. So it will go something like for I for dash in range on num rows. So there are like 4 rows. So 0, 1, 2, 3. So we want -1. So we'll go -1. So it will only go 0, 1, 2, and then stop because we only have to take 3 steps. Now this will also work if we have 1 and 1 because this will not move. And then we just add that element to the result dot append. We'll go matrix. We'll go I plus is equals to 1, and then we have to just go I. Sorry, this is number of columns should be. Number of columns, and then we'll go j plus 1, I, and then j. So it will be first we start here. We have already added this. Now for this many times, we are moving one step ahead and we are adding this element. After we reach this point, we have to do the same for like going down. So for I dash in range num rows -1, we have to go like 0 and 1 only. We'll update I and then put that into result. Matrix ij, this logic remains same. So now we have like we traverse this. Now all we have to do is traverse this way for again the same amount of times, and then traverse this way by doing -1, and then do -1 this way. So every time we reach here, like this logic is complete, we can do like num reduce the number of rows by 1. We have to traverse 1 row less. But then when we go down, we have to go 1 column less. 1 row, 1 column, 1 row, 1 column. So 1, 2, 3, and then it will go 1, 2. So these two being same is an issue because how many times is this supposed to be same? Let me just draw that on my notebook. If we had a bigger matrix, like suppose 5 by 5, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. We'll have to go 4 times in this way, then all the way down, then all the way here. Then 1 is reduced from the row, and then 1 is reduced from the columns, and then 1 is reduced from the rows, and then 1 is reduced from the columns, and then 1 is reduced from the rows, and then 1 is reduced from the columns. So we're continuously reducing 1, but we don't do that after till we reach the up point. So the first time we start traversing up, after that we keep reducing these numbers one after another. So maybe what we can do is just increase the first one or just exempt the first one, because this has to go all the way to the beginning. We can also use start and end points maybe, like if you reach this point, then do -1. So what will that look like? Uh, we have our number of rows. That is the length of matrix. We have our number of columns, which is the length of matrix of first row. And now we have to like start of I. I will be moving rows. So start maybe just rows, 0, and then end rows is equals to, so when do we reduce it? So currently it's supposed to go till 0, 1, 2. So we can do a number of rows maybe, and then start columns is equals to 0, and end columns is equals to num columns. Each time we hit this point or this point or any point, we reduce it. So we start with 0, we go 1, 2, and then we reduce the end by 1. Right. As soon as we reach is equals to this point, we reduce the end by 1 so that we never go to this row again. And this column again. And then when we reach this, we reduce the end so that we don't go to this row ever again. And then we reduce this. Then we reduce the start. And that can make sense. So we will be iterating. And since we are iterating over all of the values one by one, what we can do is we can just keep increasing I, and then we have to alternate between them, right? So now we have figured out like how to update this values. We'll go start rows and then start columns. Okay. And then if there is only one, then we start at that position, start row and start columns. Then we move our I so that it is at some other location. You have to also figure out like the turn. If the turn is 0, 0 means move I, and 1 means move J, and direction of I is initially +1, and direction of J is also +1 initially. Or we can also do 0. So initially, we will just go for I in range. Total elements we can find out. Total elements is equals to num rows times num columns. So this will be 3 into 3, 9. So for dash in range total elements, we will just keep iterating one by one. And then for each time stamp, basically for each iteration, we will do calculate our next location, which will be like our I is equals to current I plus direction I. Right. So we also have to initialize I and J. So if we start at like 0, then direction I will take us to 1, which will be like out of index. And J will also be updated like with this simple logic only. Direction J. And we will update these two variables to like control where I and J are going. Ideally, this should be started at 0, 0. So what we can do is we can first either we can first move it, because either we start at minus 1 0 so that it moves to 0 0, and then we change the direction and we start moving this way. But that also puts it at an issue, which is that it should not be that. So I and J, can we just do result dot append? So this has to be ideally be done at the end, because we need to move first and then we just append whatever is in the matrix at this position. So we have to start at like minus 1 0 so that we end up eventually at 0 0. Now we have to decide where to go. So we are at 0 0, and then now we have nowhere else to go. So if I is equals to end of columns, sorry, first we are moving row wise. So if J is equals to end columns, which will be 1 in this case, but we are not there. I don't think we'll ever get there, so it will be minus 1. If we are at this position, then we have to start moving in the I direction. Right. So we put direction J is equals to 0, because no need to move direction J is equals to 0. We also have to update end columns, that this column should not be revisited. And then we also have to update the direction of I, which will be currently it was 0. So maybe we can do minus 1. So we just keep flipping it. 0 minus direction I. So this will become 1. But that puts it at an issue that what to update, what not to update. Let me think about it. We can take like the fixed number of iterations. We know that much we have to do. We know that we have to update this ending positions so that we can keep track of like which columns and which rows we have visited already. And then we have to update the iterators. Now the updation of iterators is the main thing that's causing an issue because we started 0 and 1, 0 and 1. But if there is only one element, then we don't have to go over that twice. So we have to decide like what's the next element and whether that should be visited or not. Uh, so if I is equals to end columns, which is like 1 minus 1, if it is already there, don't do anything. Right, we don't want to append that. So like result dot append, we know we have at least one always, so it will be matrix 0 0. We have already appended the 0th element. Now we can check if like I is there. Also, I don't think this is the correct approach. We are not now going over all the elements. 1, 2, 3, 5, 6. So we are still going over all the elements, but if we are at that position, then just update it. If I is equals to n rows minus 1, then we just do n rows is equals to minus 1. So if you are at 0th column and you have only one column, just maybe we can just remove it from here so that if you are on the end rows column, you do minus 1. That okay. Now the rows are even less. We will consider this row. And similarly, if you are at if j is equals to n columns, then we reduce this by 1 because now we don't have to consider that. So if we start at like our start is 0, end is 0, and similarly for row and column, this is also the same. And we reduce that by 1 if we are already there. And how do we check like we go over this element once at least? So for this, uh, we will add this element only. Now, what we can do is just like result dot append I matrix I and j. So this is where we start. And then we update the thing. So suppose we have two things. We have 1 comma 2. So first we will start here. We have already added 1 in our result. Then we will check if I is equals to n rows. So this is the last row. Actually, this is the last row, but we don't want to check this every time. We have to also consider the turn we are at. So if we are moving in direction I, if turn is equals to I, and it is the last row, then we minus this one. And if the turn is of j, then and it is the last column, then we minus that one. We'll start by moving in the j direction, and I will not be moving. And total elements will be num rows, num columns. I is equals to 0. J we can start at 0 because we are appending the 0th element here. So we appended 1. Then we went, is this the direction? No. And then is this the direction? Yes. But are we at j is equals to n columns? N columns here will be 1. So we are not currently here. So we don't update that. So this will be the only condition when that will be updated. And when we reach this point, when we have updated j, we also have to update like, okay, now the turn goes to I because we have reached the end. So the turn also shifts. And then we start moving in the other direction. And the direction will be like whatever it was before. So if it was 0, it will go 1. Then it will go -1. So maybe we can keep this as 1 as well, because currently we want to like first move it in the positive direction. Then while we are updating this, first we don't update this, like, because, okay, so we can update of direction of I. So direction I, next time whenever we move, we will go in the opposite direction. And similarly for when we reach the end of J, the next time we move, we'll go in the opposite direction. So that will be like, first we move +1, +1, +1, +1, +1. And then at this point, we say the next time I will move in the opposite direction. And then if the turn is of I, then we update I, and else we update J. Right, because they both can't be true at the same time. So, and then we have the updated thing. So first we'll come with 1. So let's just take the case of just 1. We have I is equals to 0, j is equals to 0, n rows is equals to 0, and n columns is equals to 0. So all of those are 0. We will only iterate once. So we will only come here once because there is only one element. And then we will check if I is equals to this, then check currently the turn is of j, because first we'll move column wise. So it is true. We will mark that reduce one column. Turn will be changed. Next time will be changed. And since the turn is of I now, because now we have to move in the I direction, we will move in the direction +1. But it doesn't matter what this ends up because we are not coming back in here. So this should ideally give us a result string, a result array. We start with this. We have starting and ending. Okay, so we have to consider this as well. Okay, so In this, another thing we have to consider is the current direction now. So a lot of things depend on that. So this will become a little bit more complicated, but if turn is I, okay, then of course we have to do, this will remain at last because this will depend on whose turn is to update the thing. If turn is of I, else the turn is of J, then we'll write our logic. This will depend now on direction as well. So if direction is equals to 1, then we will, uh, uh, if direction is 1 and we have reached the end row, then we'll follow this. If direction is -1 and we have reached start, then we will update start rows +1. Direction will also change and this will also change. Else we will write similar logic for columns. So we can just go and change this to columns. Turn will change to I and direction of J needs to be updated. Right, so this will take care of both directions. And then based on whatever the result was here, we will go and update the I and J and append the next element in the next turn here. Let's try running this once. Name direction, okay. Needs to be direction. Instead of direction, it needs to be direction I. And direction J. Index out of order, we are getting I and J should ideally have been like that only. But for safety, let's see where we are going wrong. So we're going 0, 0, which is correct. We have to go 0, 0 first. Then we are going 0, 1, 0, 2, and then we are accidentally going 0, 3. So that should not have happened. 0, 3. So this is not being correctly updated. So let's check if we are even entering here or not. Print entry. Case 1. Case 2. So we are entering this every time because obviously we are in J, so we enter this every time. but we are not entering any of the cases. So direction J. Okay, so I accidentally left this out. J. That's why it's a bad idea to copy paste code with I's and J's. Okay, so let's see how we are going. We go from 0, 0, then 0, 1, 0, 2. Then we enter case 1. We go I, 1, 2, then 2, 2. Then we go 2, 1. Then we go 2, 0. Then we go 1, 0, which is correct. But now we were not supposed to go 0, 0. We were supposed to go here. So why did that happen? Because we accidentally mentioned that our this should be even less. So since we started at row 0, I guess we have to mark this as 1. Because we are already at the row 1 when we start, and we don't want to come back there. Now this might obviously will not be the most optimal solution, but let's try running it once again after removing the comments. And we are still outputting something. And then we can try submitting it once. It apparently worked fine, but let's see how we can improve it further. Because we are iterating basically however times we have elements, we are iterating iterating of n into m times, which like you have to iterate over the whole matrix once at least. So I guess that makes sense. But where I was thinking we can improve is this complex logic of turning, because there is a lot of if-else conditions. And if we can improve on that, that will be like much better. So let's see how we can improve on this part. We have to move in one direction, but currently we are using turn as like which turn to as a check. Mm, can we keep coordinates instead? Like, we can change the direction to be 0 maybe. Like, I will be always be updating with direction I and direction J, but it can turn to 0 in the when it is like not doing anything. And also, I think we can simplify these checks. So currently we're checking a lot of things. We can go with turn of I or J. We can maybe use a tuple to say currently it's a 1, 0. Sorry, we start with 0, 1, and then we will go 1, 0, then 0, 1. Sorry, then we'll go 0, -1, and then we'll go -1, 0. So this is all we have to update. Like every time we reach the end of some position, we just move to the next combination in this list. So we can create a list and just move to the next thing whenever we reach a endpoint. So we reach 0, 1 to this endpoint, we just switch to the next one, 1, 0. And then we go to this endpoint, we can just switch to 0, -1. Then we reach this point, we can go to -1, 0. So this can save some amount of computation for us. But then we have to still take care of where we are moving. Maybe we can also do that by checking which one is true. Let's just ask Grok something. Is -1 a truthy value? True value in Python or false? So if it's like true and false simply, we can also determine like where we are moving just based on this tuple. We don't need this extra variable. And we can maybe also store the direction in this, or does the direction is okay. So we don't even need the direction then because we are already moving according to these values, +1 and -1. And these are just the directions. So if we are moving, if J is like this is true, and so if J is true and we reach this, we just move 1 plus. And we update this, and then we just move to the next thing. But no need to do this. And also this save, this will be saved. Quick answer is true. So only 0 is null, so -1. I don't stream games. I do programming streams. I am learning how to code. But thank you for joining in. Hope you like the code I'm writing. So if this is like a truthy value, 0 and 1, then we can save some of these operations. Thank you. And then let's try commenting this. I'll go to Twitch and then and yeah. Let me just comment this whole thing, and then we'll go create a copy of this part because I will just edit that. So if we have 0 and 1, then we can go we first have to create a list like moves. It will be a list of all of these values. And then whenever we reach any type of end, then we can just move to the next move. So our current move will be, current move is moves 0. And then we append this as before. If current move, we still have to like perform a check on which value is true. So I guess this does not change that much, but let's try. If current move or I is the first value is 0, if this is true, and the direction I, which is like, again, this part is 1, and we are at end rows, then we just minus that. We turn current move is equals to moves. Okay, so current move is equals to, we have to go 0. So current move will be moves, current move, and then the 0th part. Current move is equals to current move plus 1, and we just modulo with 4. And then we have this. We also don't need this. Just to current move, and then move up. Similarly, for this, it will just be current moves, this, and then instead of 0, it will be 1. And columns is this, then again, this will be the same. And then this will be the same. And then for this, we don't have to worry about this whole logic. If else condition will be saved. And then we can just go I plus, we have our current move for J. And then we also have for I. So these will be updated every time according to this list. If moves is 1, so this is to like decide direction, which direction we are moving. I guess that is important because, and we can also like remove this duplication, because if we are reaching an end, okay, that is only to be updated when we reach an end. So we cannot just put it out. Let's see, and if this gives us any errors. Okay. So easiest way will be like to find out what is I and J being updated to. I is going 0, 1, then 0, 2. Then we are going 1, 2, 2, 2. And then we're going 2, 1, 2, 0. And then this should have been updated. So yeah, this is incorrect. All right, so this worked. Let's try submitting that. Also, I should remove this and then submit. So basically, like we were able to save these two operations and simplify like how we were updating things. And as a result of that, we can also I and j are being calculated still, total elements we still need, we can remove these variables. So these variables were previously needed, but we don't need those anymore. Num rows and num columns we are using here. So we can run this again and see if everything works. Now, is there a way to simplify this even further? We have to check like which direction we are moving in first of all, and then we have to also check which if we are reaching any end or the beginning. Maybe one way we can do that is checking if we do need, because we will be at start rows and end rows, but we have to keep in mind the direction we are moving in to finalize like if we need to update that or not. I don't think this can be like further simplified much. So let's go over to solutions and see. Obviously, there will be one-liner approaches because people do that, but we are not doing that. Uh, let's see if they have a solution for this. They're going rows and columns, X and Y, and then the difference they're moving. For each of those, like we did, we append that, yeah, and then we update that to dot. Okay, so they are just updating that to dot. And if it is not this thing or not this thing, so basically inbounds, or if this is like a dot, then we flip, which is basically like a easy way to simplify this. This is like 0, 1, then we go 1, 0, minus dy. Why are they going minus dy? Because that way we are starting with 1, 0. You will end up with uh, minus 0 plus 1. Okay, so they are moving, they're just handling variables differently. So basically the same thing will happen. We just have to go that way. Like dx and then minus this way. And then we update that. And the thing they have simplified is that they are tracking which elements they have visited using a dot. So instead of maintaining a complex thing, basically if you see a dot, turn around. So we have this whole thing. Let's also comment this. And then we'll just copy simple part and our DI, I would like to call it, where DI is moving. Currently DI will move nowhere and DJ will move to +1. Whenever we append the result, we basically update it. So this has one downside. We are basically changing the original matrix, which is not desirable in all the cases. Sometimes you want to reuse them. So, but if that's okay, then we can just put a dot and then we move according to that. So at the end, what will happen is obviously I will go I plus DI and then J will go I plus DJ. And in between, we have to check that if moving in the current direction throws us out. So if I plus di will put us greater than the meaning out of bounds of number of rows minus 1 because minus of if it puts us out of this bound, or I plus di puts us below 0, then we say like time to switch because you're going out of bound. So time to switch, and we can just do that as di dj is equals to I think for us it will be dj comma minus di, because we go from 1 to minus 1, and when we go from 1 it stays 1. So yeah, it will be this change. We also have to check if j plus dj, basically the same thing. dj puts us out of columns, or it puts us out of rows. It puts us out. Then again, time to switch. And you have to check if matrix di I plus di and j plus dj is equals to dot, then we have to switch. So, but we only have to switch once because we have to check all of these conditions that if I plus di is in the range, num calls. So basically, if it is smaller than the end and greater than the start, and our j plus dj is in the columns. So if this is not true, so basically if this is not true, or this is not true, or if this is the case, then basically update it. We have three conditions. If you're going out of bound from either this side or this side, we need to be smaller. So even after we do plus, we need to be smaller. We need to be maximum num rows minus 1, and then same for j. And then both of those, wherever we land, it should not be a 0. Sorry, a dot. And if all of this is okay, like this is the only case for us to update. If we see we calculate where we are going, and then we see if there's a dot there. If there is a dot, we flip. And if we cannot go there, we flip. And we only iterate for the specified amount of times, so we don't go out of bounds at the last iteration. Num rows not defined. It's num rows. Okay, so let's see what I and j we are getting. Print if I and j. Right, because this is not true, or this is not true, or this is true. Then we update, and let's also print when we are updating. Updated at I is this and j is this. So we are updating at 0, 0, which is not supposed to happen. Okay, so this can be 0 equals to, and then this is also 0 equals to, because we can be at 0. Okay, so this is now giving the correct answer because we can be at 0. It needs to be between 0 and num rows minus 1, and it needs to be between 0 and num columns minus 1. So now if we comment this and we comment this, and then we submit or run this, we get a slightly slower speed, which is like, okay, we are updating matrix, maybe that's why, or maybe we have so many comments, that's why. But let's see. So we didn't need these ones, and then we all, okay, so this is the only thing that we didn't need anymore. We can comment it here as well, like, okay, we don't need this. And then we always need I, j, number of columns, our result to be stored. We are iterating these many times, and we are checking again a lot of things. If this is not, if range is out of bound, or we see this matrix, then we flip it and then we print it. Again, like our runtime is always like runtime complexity is again of n of m. We have done one thing, we have reduced the number of operations, the number of checks here, and we have added one update instruction, which I guess since it's like a list array operation, it takes of one time only, and in this it takes the same amount of moves. So we were doing 1, 2, 3, 4, 5, 6, 7, 8, 9 checks. Here we are doing less. So that's it for today. Thank you very much for joining. Hope you had a good stream with me. I hope you guys are coding as well. See you tomorrow.